Hello everyone, myself Shivy Roy, and today I am going to teach you a very simple topic and very simple and very important topic from class 11 physics. Okay, so today's topic is conservation of linear momentum, and we will further know about this more clearly. Okay, what is conservation of linear momentum? Let us first study the statement of the conservation of linear momentum. What it is? Under no external force, the total linear momentum remains conserved. Let us understand more clearly what it is. Under no external force means that there will be no external force on the object, but the linear momentum before collision is always equal to the linear momentum after the collision. Okay. So another statement is when no external forces applied on the object of system, the change in momentum before the collision is always equal to the change in momentum after the collision. So this is the statement of conservation of linear momentum. So eventually we will prove how does this statement we will prove further. Okay. So this was the statement of conservation of linear momentum. Let us prove it. Proof. Okay. Let us consider two objects. One is A and another is B. And both of the object, we are considering this as a system. Okay. Suppose we are taking two objects of a system, and object A has mass m1, and let us consider the object B has mass m2. Okay. So before the collision, suppose we are considering the linear velocity of object A1 to be u1 and the initial velocity of the object B is u2. We are considering let the initial velocity of A is greater than B. Okay, we are considering this. This is before collision. So after some time, delta t, what happens? The two objects is moving in a single direction and the velocity of object A is greater than object B. Then after some time, what will happen? After time delta t, the two objects will collide each other. So this is before collision. So during collision, what happens? This is during collision, means they will collide with each other, means the object A and object B are colliding with each other. Okay, this is during collision. This is object A and this is object B. So all of this is happening under no external force, means there is no force there is no force acts on this system from the outside. Okay, no external force. So what does happen after the collision? So after the collision, the two objects will again move with their final velocity v1 and v2. This is for object A and this is for object B. They are having mass m1. Object A is having mass m1 and object 2 is having mass m2. After collision. So all of this we are considering before the collision, and this is during the collision, and this is after the collision. Let us prove it now. So from Newton's second law of motion, basically we are proving the derivation from Newton's second law of motion as well as Newton's third law of motion. Okay, so we know what is Newton's second law of motion. The rate of change of forces equal to K, means constant, dP by dt. Okay, so now we'll understand this concept more clearly. So when during the collision, the object, let us consider the force AB, means force FAB means the force is applied on object A due to object B. And what is the force on B? That will be FBA. FBA means the force on body B due to body A. Okay. So we'll find now FAB and FBA. Okay. So what is the value of FAB? Force on A, body A due to body B. What it will be? FAB. From Newton's second law of motion, what is force? Force is rate of change of momentum. Okay. So we will now write the force on A due to B. So it will be change in momentum of body A divided by dt. This means dPA means the change in momentum on body A divided by dt. This is from Newton's second law of motion. Force is the rate of change of momentum. Okay. This is equation 1, and further we can solve this. And what is the change in momentum for body A? Before the collision, what was the momentum of body A? Mass was m1 and the initial velocity was u1. Means, what is the formula for the linear momentum? Mass into velocity. So before the collision, the momentum of the body A will be m1 into u1. And after the collision, the momentum of the body A will be m1 into v1. m1 is mass for the body A and v1 is the final velocity of body A. So what will be the change in momentum for body A? The final momentum of body A minus initial momentum of body A. Okay. So it will be m1 into v1 minus m1 into u1 divided by dt. Okay. So we are considering this as equation 1. This is the value of FAB. Now we will find out the value of FBA. What is FBA? Force on body B due to body A. Okay. So what it will be? The rate of change of momentum of body B divided by dt. The rate of change of momentum of body B, how we will find out that? So final momentum of body B minus initial momentum of body A. So it will be m2 into v2 minus m2 into u2 divided by dt. This is equation 2. Okay. Now further, we know from the Newton's third law of motion, Newton's third law of motion, we know that every action has equal and opposite reaction. So you can see here, this is the action force and this is the reaction force. So FAB will be minus of FBA. Means their forces are always in equal magnitude but they are in opposite direction. And we know this from the Newton's third law of motion. Means every action has equal and opposite reaction. Means force on body A due to body B will be negative of force on body B due to body A. So from equation 1 and 2, what we can write in this equation means m1v1 minus m1v1 minus m1u1 by dt. This is from equation 1 is equal to minus of FBA. What was FBA? m2 into v2 minus m2 into u2 divided by dt. So for further solving this, equation, what we will get, dt can be cancelled because both are same, both sides. So let us solve this more. So from that equation, what we can calculate now, m1v1 minus m1u1 is equal to minus of m2v2 and minus plus m2u2. So after rearrangement of this, after rearranging both the equation from both sides, what we will find now, m1u1 plus m2u2 is equal to m1u1 plus m2u2 will be m1v1 plus m2v2. m1u1 plus m2u2 is equal to m1v1 plus m2v2. So this is the final statement. What does it means? So the momentum before the collision is always equal to the momentum after the collision. Okay? Hence, proved. Okay. So this is the momentum before the collision and this is the momentum after the collision. Hence proved. So from this derivation, what do we understand? That the under no external force or the under zero external force, the rate of change of momentum of body, rate of change of momentum of a system will be before the collision will also be equal to the momentum after the collision of the system. Hence proved. Hence, under no external force, the rate of change of, the change in momentum is always equal before and after the collision. So this is all about conservation of linear momentum. Thank you so much.